Okay, here's an ALEKS problem involving predicting the formula of binary ionic compounds. I like this particular example because it gets to the point of how ions combine to form binary compounds. So a binary compound has two parts. In these ionic compounds, those two parts would be a metal, which remember, metals generally are positively charged, so they're cations. And nonmetals are generally negatively charged, so they're called anions. Cations positive, anions negative. So the two metals that are given are magnesium with a charge of +2 and chromium with a charge of +4. The two anions are bromide, which is a bromine atom with a -1 charge. Remember, if the charge is 1, we don't write the 1, we just write a negative. Or if it's a positively charged ion, if it's +1, we just write plus. And the oxide ion, which is an oxygen atom that has a charge of -2. And let's remember also that we can predict at least 3 of the 4 of these based on their positions in the periodic table. Magnesium is in the second column, group 2A. That's an alkaline earth metal. It therefore has a charge of +2. The bromine, which is in group 17A, I'm sorry, 7A, is a halogen, so they have a tendency to form -1 charges. So that's the bromide ion. And then oxygen, which is a chalcogen, that one is in group 6A, so that one tends to have a charge of -2. You can't really easily predict the chromium. That's why the charge is given here, in a sense, is because chromium could have different charges. It's a transition metal. Remember, the transition metals have different possibilities. So it says in here to write the empirical formula for at least 4 binary ionic compounds that could be formed from the following ions. And it's important to note that ionic compounds are essentially based on what's called electrostatic attraction. If you have a particle which is positively charged and it is placed near a negatively charged particle, they feel attraction towards each other. So ionic compounds are really just the case where a metal ion, which is a cation, is attracted to the nonmetal, which is negatively charged, and they just sort of stick together. Now, in reality, they don't stick together as simply as that. They tend to actually cluster together as if you were looking at fruit like oranges or apples stacked in the grocery store. They form these complexes which are called matrices. But for right now, all we're trying to do is we're trying to figure out the chemical formula. And the empirical chemical formula for these, all you have to do is you take let's take, for example, magnesium, and we know it has a charge of +2. It's not going to form an ionic compound with chromium because they're both positively charged. If you have positively charged ions, they're going to repel each other. It's repulsion. So they don't form compounds. If they have the same sign, meaning they're both positive or they're both negative, they do not combine together. So the magnesium, therefore, could combine with a bromide. It's possible because the bromide's negative and the magnesium's positive. Or it could combine with the oxide. Again, the oxide is negative, so magnesium can form a relationship with oxide. So here's what you do. The idea is essentially this. They will combine, meaning the cations will combine with anions in small numbers. You're not going to see magnesium 54 oxide 32. They tend to form very, very small relationships, 1 to 2, maybe 3 to 1 or 3 to 2. But even rarely are you going to see like 4 to 7 or anything like that. It's generally 1 to 1, 1 to 2, 1 to 3, or 2 to 3, very, very small ratios. Okay, so you don't have to worry about these gigantic numbers with these combinations. Here's what you do. Let's take the magnesium, which has a charge of +2, and the bromide, which has a charge of -1. The magnesium has a larger charge. It's 2. 2 is more than 1. So what you do is you say, okay, magnesium is +2. And bromide, thinking about this physically, is -1. These charges are not balanced. There's more positive than there is negative. Ionic compounds form when the amount of negative charge is equal to the amount of positive charge. So the simplest way for this to work out, and that's really what the empirical formula is the simplest formula, is 2 bromides will combine with 1 magnesium. That's the simplest possibility that ensures that the negative charge has the same size as the positive charge. Now, what do I mean by that? If this is -1 and this is -1, what's -1 and -1? Combined, that's -2. So the -2 combines with the +2, and they are said to neutralize each other. They both have the same magnitude, the same amount of charge. Obviously, they're opposite charges. We're not saying they have the same charge identical. What we're saying is they have the same magnitude of charge, the same size of charge. So what you would see then is 1 magnesium and 2 bromides. And the way we write that is we write, if it's a 1, there's only 1 magnesium. We don't write any numbers. We just write the symbol. So Mg, no charges. We're not writing charges. We're not going to put +2 or anything like that. Then how many bromides are there? There's 2 of them. So we write Br2. So this says the formula is 1 magnesium, 2 bromides. The name for this is magnesium bromide. Oops, sorry, bromide. You name the metal, then you name the nonmetal, bromine is the nonmetal, and you change the ending of the nonmetal to IDE. So magnesium bromide, not magnesium dibromide, this is a common mistake. For ionic compounds, a metal with a nonmetal, you're just going to name the symbol for the metal, magnesium, then name the nonmetal and change the ending to IDE. MgBr2 would be our answer for that one. That is a possible formula for a combination of magnesium and bromine. So now, magnesium and bromine, I should say. What I'm going to do is I'm going to erase this. And we're going to take a look at another possibility. What if the magnesium combines with the other anion, which is oxide? O2-. How's this going to work? Well, again, the idea, the principle behind this is they will combine in small numbers. That's what's observed in terms of their ratios. 1 magnesium to 1 oxygen, or 1 magnesium to 2 oxygens, or 2 magnesiums to 1 oxygen. Small ratios. What is the smallest possible ratio that ensures that we have the same amount of positive charge as we have negative charge? Well, the magnesium is +2, and the oxygen is -2. So if you just combined 1 and 1, they would have the same charge. Here's how we might write that as a picture. Mg2 plus, O2-, 1 and 1, right? There's only 1 of each, and they have the same amount of charge. One's +2, the other one's -2. The empirical formula, what you do is you count up how many magnesiums you have. There's 1 of them, so you write Mg. You count up the number of nonmetals, how many oxides you have. There's 1 of them. And that would be the empirical formula. The empirical formula is the smallest ratio of atoms of each element in the compound. So there's 1 magnesium for every 1 oxygen. Okay? So all you got to do is take a look and see if the charges are equal. The ratio would just be 1 to 1, and you would write the formula as MgO. And this would be called, again, magnesium. You name the nonmetal, change the ending to IDE. It's not oxygenide, it's actually oxide. So anything that says oxide, they're talking about the O-2 charged ion. This is an atom of oxygen that has a charge of -2, just as magnesium is a magnesium atom that has a charge of +2. Okay, so there's another possibility. Let's take a look at a third one. We did the magnesium. Those are the only 2 possibilities, really, that we could get out of this for magnesium. But we also have chromium, chromium-4. So Cr4+. And let's combine it with the first one, which is bromide, Br-. Okay, So this has a charge of +4. This has a charge of -1. There's more positive than there is negative. So that means we need more than one bromide, right? We're trying to get up to the same amount of charge that we have on the positive end. So if we just have one chromium, so there's only one there, we would need 4 bromides, right? You need 4 of them to combine with the chromium to balance the charge. +4, -1, -2, -3, -4. We now have -4. Again, the formula is written just by counting the number of ions. You do the metal first. So one chromium and 4 bromides. So CrBr4. This one has a specific system for naming. This one would be called chromium. Again, you name the metal. But in this case, because chromium is a transition metal, with transition metals, we use a system called the stock system, where we put the Roman numeral 4 to indicate the charge of the metal ion. And then again, you just name the nonmetal, change the ending to IDE. So chromium 4 bromide. Okay, so there's that one. It's a 1:4 ratio, 1 chromium for every 4 bromines. If you actually analyze the compound and tried to measure what the ratio was, you get a 1:4 ratio there. Okay, got one more possibility here, and that is, what if we took the chromium 4 and we combined it with an oxide? Well, we can't combine it 1-to-1 because the chromium has more positive charge than the oxide has negative. So what you do is you just do counting. If this is +4 and this is -2, this one's more than that one, so we need more than one oxygen. Well, think about it this way. You can do a picture. If one oxide is -2, we need another oxide, right? A second one would give it another -2, so now you'd have -4. So it looks like there's 2 oxides for every 1 chromium. So 1 chromium, 2 oxides. And this 2 is not the charge of the oxide, it's the number of oxide ions to make this very simple formula. So CrO2, and the name of this would be chromium 4. Again, the 4 is the charge of the ion which we were given in this problem, and then oxide. You name the nonmetal, change the ending to IDE. So chromium 4 oxide would be the name of this compound. Transition metals have the Roman numeral system there. Okay? Just so you know, one other possibility, what if we had, for example, chromium 3, and let's do oxygen -2. It's not so simple now, right? Because if you did 2 oxides, that'd give you -4, which is more than +3. So what do? Well, the small ratios, 1-2, 1-3, 2-1, 2-2, I'm sorry, 2-1, 2-3. Generally, for these types of problems, you don't usually go up to more than 2-3 ratio. But here's the way to think about it. If chromium is +3 and oxide is -2, one way to deal with this is to say, okay, let's put a second oxide in there. But now we have more negative than we have positive. Well, then add one more positive. So another 3+. So now we have +6. +3 is +6. Do one more oxide. Now you have -2, -2, -4, -6. +3, +6. So it looks like we need 2 chromiums, so Cr2, and we have 3 oxides, so O3. And generally, I'm not going to make any claims that this is for sure, generally that's about as complex as these get. So this one would be called chromium 3. It's called chromium 3 because the charge of the chromium was +3. And then the oxide is just oxide, just like we've done before. So chromium 3 oxide would be the name of that one. So Generally, you're just getting these very small ratios, 2 to 3, for example, 1 to 2. Remember, if it's a 1, you don't write the number. Do small ratios just to get these empirical formulas. Okay, hopefully that helps you out.